Okay, got a video here that I made to try to help Alan Burgess. Basically what we have here is a fairly simple schematic. We've got a plus and minus supply. We've got a couple of LEDs, one connected in the forward direction, one connected backwards. We have a basic coil. We have another LED and a rectifier diode which I took out. Don't really need it. It was just in there as part of the demonstration. Let me connect that back up. It's basically just a blocking diode, which we don't really need, but I put it in there to make it a little clearer to understand exactly what's happening. Okay. What we should see is the one LED lighting. When we release the disconnect the ground, we should see the other LED light. Power on, power off. Power on, power off. Power on, power off. Power on, power off. You notice this LED? It's not lighting up. Alan insists that current reverses and goes back into the power supply. How can it when we've got the power supply disconnected on this side? The current doesn't reverse. When we remove this, the current continues to flow the same direction, goes back to the LED, back to the blocking diode, back to the coil, because the coil has become the source. It can't magically put power back into the power supply. It's not connected to it. We don't see the reverse LED lighting up. The reverse LED is good. I can switch it around the other way. And you'll see both LEDs light up in the power supply line. And we still see the other one lighting up when we remove the power. We don't need the blocking diode, actually, because LEDs are diodes. We remove that. Same thing. Our power supply LEDs light up. The one across the coil lights up. If we switch the direction on the one across the coil, it's going to be reverse biased and it may blow it. But because they don't stand a lot of reverse bias. Now, it's actually lighting. See, it's lighting as we apply power, and then the coil takes over. It's lighting because the voltage goes up across the coil, and as the coil starts taking current, it goes out. But when we let off, it doesn't light up. I hope this demonstration is clear enough that Alan can understand and anyone else is confused about this idea of current reversing in a coil can see from this simple circuit the current does not reverse in the coil when you remove power. It just continues on back through this side. That's why when you've got a transistor down there, you put something in there to let the current bypass from the transistor, from inductance and all. Normally you put it across the coil. That's the way you usually connect something if you want to suppress that surge. You just put a diode across the coil, it sits there and takes the inductive kickback, and you don't over voltage the rest of the circuit trying to pulse it. Thank you for watching.